All right, hello and welcome. Here we are, another question. This is going to be find the smallest divisor given a threshold. Medium LeetCode 1283. Let's just take a moment to make sure that the audio is working before I begin. Medium LeetCode 1283. Yep, that's working. Pop out the chat. What else do I want to say about this? Not much to say other than get going shortly. So, okay, very good. Good to go. So here we go. This one has a much lower acceptance rate than the other one. The previous question was I think a lot easier. This is hopefully a little bit more challenging. And it'll take a little bit, possibly take a little bit longer, we'll see. Given an array of integers nums and an integer threshold, we will choose a positive integer divisor, divide all the array by it, and sum the division's result. Find the smallest divisor such that the result mentioned above is less than or equal to the threshold. I think this is a linear binary search question. Each result of the division is rounded to the nearest integer greater than or equal to that element. For example, 7 divided by 3 is 3, 10 divided by 2 is 5. Yeah, using integer division. Greater than or equal to that element. Oh, excuse me, it's not integer division, it's actually the ceiling. Oh, that's annoying. Okay, test cases are generated so that there will be an answer. Yeah, in C++, usually it's actually the other way around. So it really, yeah, just gotta take the ceiling. I need to use floating point arithmetic and take the ceiling. So 7 divided by 3 should actually be 2, not 3, but whatever. The way they're doing it is a little bit different. It's fine. So 1259, threshold is 6. We can get a sum to 17. Divisor is 1. Sum of 7, the divisor is 5. Yeah, so binary search works very well here. I'll explain in a minute how exactly to do that. So I just need to get the sum to be above the threshold, right? Smallest divisor such that the sum is less than or equal to the threshold. Excuse me. Okay. Smallest divisor is less than or equal to the threshold. Oh, I see. No, actually, that's really confusing. What are we trying to do? We want to be less than the threshold. So here, this is above the threshold. Here, this is above the threshold. Here, this is below the threshold. And if I go too far up, I can do other things that are above the threshold. Divisors that are above the threshold. But yeah, divisors that are larger, I could do larger divisors and the sum will be below the threshold still, but those divisors are larger. So if I did a divisor of 6, or let's do actually 10, divisor of 10, then I'll get a 5, which is below the threshold, but I want the smallest divisor. Okay, it's a little confusing, but it still is okay. It still works. So yeah, this is you could do a binary search for this. Just have A. I'll explain in a minute how exactly it's going to work. Divisor has to be at least 1, I think. And the largest divisor could be really nums.size, right? Not nums.size, it could be 1,000,000. Yeah, just do 1,000,000. It's fine. While, and we'll just take best. And we'll just say that's 1,000,000. What if it's not possible? It's guaranteed there will be an answer. I was gonna say it could be not possible in some cases. So we're gonna have a check that happens, and if that check passes, so what I'm gonna do is check for a particular divisor, does the calculated value exceed the threshold or not? If it exceeds the threshold, then I need to, let's make that the check. Then I need, if it exceeds the threshold, right? Sorry, I'm thinking. If it exceeds the threshold, then I need a larger divisor. I need to go to the right. If it exceeds the threshold, I need to go to the right with a larger divisor, which means that A plus B minus A. Yeah. So we'll come back to that. If it exceeds the threshold, then I want a larger divisor because I need to bring down the threshold. A larger divisor means A is mid plus 1. And if it doesn't exceed the threshold, let's say it doesn't exceed the threshold, it's less than or equal to the threshold, then I want to go to the left and try to get a smaller divisor, potentially smaller. And I could save this divisor and update my best value now. Okay, a little confusing, but that should be relatively clear. And the calculation itself is just going to be for each constant x and nums. Say int amount is just going to be amount plus equals x divided by mid. Now it's going to be convert to a floating point and then divide by mid, and then take the ceiling. Yeah. Then also gets converted to an integer before it gets added to an amount. So hopefully this works. I may have to do more conversions there. And then we just say if the amount is greater than or equal to the threshold. If it exceeds the threshold, then we need to go to a larger divisor on the right side. If it doesn't exceed the threshold, then we want to go to a smaller divisor and save the best divisor that we got so far. So those are going to be the things to consider. Okay, what are we doing on time? Wrong. Ouch. Output 1,000,000, expected 44. Of course. What? Threshold is 5. What happened? What? And this should be, it's binary on, it's a logarithmic on 1,000,000, and then it's linear on, so if it was like n, O of n times log m, where m is the largest number. I think this is a little bit confusing, yeah? Why shouldn't this just come all the way down? Oh, excuse me. No. That's what's wrong. Okay, it's got to exceed the threshold, not be equal to the threshold. Yeah, okay. I think this is it. I'm gonna go for it. I'm just gonna go for it. I could be wrong. There's a good chance I missed something subtle, but I'm just gonna go for it. Oh, got it. Okay, not bad. All right, so not terrible. Took 8 minutes. Not terrible. I kind of immediately recognized the answer, like the sort of problem and solution. Let's do submit it 4 more times and then go on the next question. I don't want to spend too much. There might be a faster solution that's like linear, isn't a binary search, but this is a very simple approach. I like this a lot. It's really easy, quite frankly. Also, this summation maybe could be done using a like an STL algorithm, but you really don't need to do that. I know some people, 1, 2, 3, 4, 5. Some people like really make a big deal out of it, but I don't think it's that important to be that concerned about that. All right, I'm going to submit one more time, and then we'll go on to the next question. So if you like this video, give it a like and subscribe for more, and we'll keep going. What I'm going to do is I'm going to stop the stream here and restart it on a new question. So I'll do that in just a moment. Okay, 91% is pretty good. It's reasonable. All right, thank you for watching.